In Chapter 2, Section 1, Whole Numbers, we're going to be learning how we actually formed counting and numbers and whole numbers specifically. So this is going to be kind of like a little bit of a crash course, if you will, into the history of mathematics, where we go all the way back to the beginning and we think about, okay, well, how did we come up with all this stuff? All right. So in the previous chapter, we were learning about sets. Okay, and remember, just to recall, sets are nothing more than a collection of objects with something in common. All right, and like I said, we learned about some different sets and everything, but the big idea is, well, where did all this stem from? So archaeologists, as they were studying different, ancient sites and stuff like that, they started noticing a pattern within, within like bones. Okay, and what they noticed was, and please do not make fun of my artistic ability, but I'm gonna try to draw like a little bone here. There we go. And what they noticed was, on the bone itself, there were like these like little dash marks, kind of like this. Some of them may have had like a little X on the side of it and everything like that. Okay. And what we deduced from this is that whoever had this bone was actually counting something. Okay. Whether it was sheep going out into the pasture, right? They would put like a little dash on the bone. And when that sheep came back home at night, they kind of cross it out to make sure that, okay, I had one sheep go out and one sheep come back in. I'm good to go. So all of this started really to take place when you think about like a child, uh, when they start learning how to count. Because if you think about a kid counting, right, when they learn, kids don't start at zero. Like nobody says, okay, zero. They start off at one. And the reason why is, well, they can see the number one in their hands. They can put up their first finger and say, well, that's one. And then they put up two fingers and two. And we call those natural numbers. Because naturally, we started counting off at the number one, and then two, and then three, and so forth. Okay? So that's really where all this started to come about. All right? Is the idea of numbers. Okay? Is like counting something. All right? Now, there are patterns in which we do this. For example, for us, we use base 10. All right. And the pattern that we've developed is we start off at technically 0. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you notice the number 10, it starts over. This pattern starts over. But now we introduced what we call a place value. So the number 10, then we have a number 11, 12, 13, and so forth. I mean, this pattern starts over, the pattern starts over again. It just repeats itself. So we started introducing what we call place values. Okay? So place values determine like how much. All right. Like, for example, we know the difference between 0 and 10. The reason, well, this 0 right here, we call that the ones position. However, this 10 or this 1 is in the tens position. So what we would say is we have 1, 10, and 0, ones. All right, but we know this as the number 10. Okay? So, was this always the case? Well, the answer is no. This was not always the case. All right? So, we're going to have to go into our book because I'm not exactly the best artist, and I at least want to get a really good picture of everything first. So, if we go into our textbook, we're going to be talking about first the Egyptian numeration system. All right. Now, the Egyptian numeration system was developed in a base 10 format, but they didn't have the numerical representation that we have. Like, for example, the number 1 for us is technically that right there, right? And their number 1 was very simple. Looks very similar, correct? Now, our number 10, we would write like this. However, the Egyptians, they wrote it like this. Okay, and they called it a heel or a heel bone. So let me go ahead and get all the numbers that they used, okay? So in our textbook right here, I'm just going to copy and paste this. Table 2. And here are their numbers. All right. So like, for example, across the top, here's how we represent all these values. And then in the second row, that is how the Egyptians would represent it. So for, if I go from right to left, the heel bone is 10, the scroll is 100, the lotus flower is 1,000, pointing finger is 10,000, and so forth. So the first thing I'm going to show you is we're going to translate these numbers. All right. So here's an example here where we have the lotus flower. And like I said, please don't make fun of my artistic ability. We're going to do 2 scrolls, 3 tens, and a couple ones. All right. So if you look here, there's actually a place value system here. And the place value system here would be the different symbol used. So like, for example, we know right here, we have 3 because that we have 3 ones. And then here, this would be 30 because there are 3 heel bones. Here, we have 2 scrolls. So if you remember, a scroll is 100. So this would be 200. And finally, the lotus flower would be 1,000. And if we just stacked all these numbers on top of each other, we would find that this number is 1,233. All right. So this is how they would write numbers. All right. Now, if we went the other way, let's say we wanted, so like here's the example here. Write 307 in Egyptian form. Well, the thing to remember here, and this is something that's actually presented later on in the chapter. I don't know why they waited till the end of this section to show this. I'm going to show you this now. This is called expanded form. So we know the number's 307, and we know that we work in base 10. So when I go to expand this number here, what I can write is that's 7, and I'm going to write on the right-hand side. I'm going to put parentheses around this stuff so you can actually see it. So that 7 is really 7 times 10 to the 0. All right? The 0 is 0 times 10 to the first. And then the 3 is 3 times 10 to the second. Because when you look at this, 10 to the 0 is 1. So this is 7 times 1, or just strictly 7. Plus 0 times 10 to the first. Well, 10 to the first is 10. And 0 times 10 is 0. Plus 10 to the second is 100. And 3 times 100 is 300. So this is what we call expanded form. Expanded form is right here. All right. So how can this help us if we're using if we want to convert this number into Egyptian numerals? Well, if you just use that chart that I gave you, which is right here, here we can see we're going to need 3 scrolls. And we're going to need 7 of these dashes. So let's see here. 1, 2, 3, 4, 5, 6, 7. Okay. Now, here is the number 307. But there's a problem. And hopefully somebody can see the problem. Okay, if you don't see the problem is spacing. All right. So the way that I wrote this, the Egyptians would actually really exaggerate. 1, 2, 3, 4, 5, 6, 7. They would really exaggerate this. All right, because they wanted some space here. And you're going to see why the spacing actually plays a major role later on in this section when we talk about Babylonian numbers. Okay? So here's just a simple way on how Egyptians would write numbers and stuff like that. Now, the next set of numbers that I'd like to go over would be the Roman numeration system. So Roman numerals. All right, so let's go ahead. Let's go back to our text, and we're going to get that table out. So here it is right here. So this is table 2-3. All right. So the Roman system was all about writing numbers as small as possible. All right, they didn't want to write a lot of stuff, and they could develop tools that would write these numbers very quickly. All right, so we're going to start off simple. So given the number mxi, what is this number in decimal form? Meaning base 10. Okay? So if you just kind of like scan down, m is 1,000 plus x is 10 plus I is 1. So once again, if you just stack them on top of each other, we would end up with a number 1011. So it's pretty straightforward. Okay, but there was an issue. All right, there was an issue with this, which is the Romans never wrote the same symbol more than 3 times. Now, you've seen this before, okay? For example, we know in Roman numerals this is 1, right? Then 2 looks like this. 3 looks like this. But 4 is this. And then you have 5. So they use this idea of the, it's called the, I think they call this subtraction principle, or the subtractive aspect. All right. And the way that this works, all right, is, and I'm going to get the table out again. All right. So the way that this works is, obviously we can see that as we go down the column, the numbers get larger and larger and larger. Now, we have the Roman numeral equivalents on the far right side, okay? And if a number, let me say it this way. If a Roman numeral that is smaller in value appears before a larger value, that is the subtractive aspect that we were talking about. So, for example, the number 4, which we know as the IV, right? Notice that because this I is appearing before the V, we're going to subtract 1 from 5. And that's why they wrote it like that. Okay? So, for example, all right, if we wanted to write the number 49, we would write I and then an L. All right, because L is 50, I is 1, and that's that subtractive. Oh, I didn't want to do that. Sorry. There we go. So here's that I, and this is how you would write 49. All right. So it's like one of those things where they didn't want to have like a big long number. So they just condensed it by using this idea of the subtractive property. Okay? Now, the next set of numbers we're going to look at are called the Babylonian numeration system. Okay, and the Babylonians, they had one tool that they used to write their numbers with, okay? And this was like, it was kind of like a staff, okay? And it had two symbols on either sides, all right? The one side would give a symbol that looks like this. All right, so here's our symbol. And this represented the number 1. The other side looked like this. All right. And this represented 10. And that's it. That's all they had. Now, the crazy thing about the Babylonians, all right, is their base or their number system was not based off 10. They were base 60, okay? Which means when we count, all right, so here's the differences between base 60 and base 10. We know when we count 0, 1, 2, 3, all the way down to 9, and then it repeats. And we introduce what we call that place value thing, right? For the Babylonians, it was 0, 1, 2, 3, and they would go all the way down to 60, and then it would start all over again. All right? It would start all over again. All right? It would go all the way down to 60 again. However, depending upon where the symbols were drawn, these symbols were drawn, would represent a different place value. All right, it would represent a different place value. So I know this is a little confusing at first, so let me go ahead and let me show you what I'm talking about. All right. So they wrote their number, and this is a great example, 23. So the number 23 looks like this. All right, you have 2 of these wedges. All right, and then 3 of these, excuse me, 3 of these staff prints. I guess that's what they called them. All right. So that would be the number 23. But here's the problem. All right. This number right here all right, this number could also it could also be 23, or, all right, it could be 60. Let me write it underneath. So this is 3 times 60 to the 0. And this could be 3 times 60 to the first. And 3 times 60 is 180 plus 3. So this number could also be 183. The problem with the Babylonian numeration system was all about the spacing. All right. If there was no spacing, if it was nice and tight next to each other, then you could call it 23. However, if there was this gap here, all right, if there was a gap, you really didn't know if these two wedges were just the next place value or if they represented the place value further to the left. So, you know, there was a definite disadvantage with this. All right. So as you do your readings here, all right, you're going to notice that they actually invented a new symbol that helps to distinguish between the number 0 to help out with the place values. And that symbol, and I'm going to write it here in purple, looks like this. So it's another wedge. Okay, it's another wedge. Except they just angled them differently in between place values. So now I would know that these two things are separated. Okay? But this didn't happen until like years later. All right? Because I guess somebody got fed up and they were like, all right, enough of this. All right? We need a better way of doing this. So like an example of this number, which would be 3,624. All right. I could write that as 4 wedges going down. All right. And then 2 of these wedges going sideways, just like this. All right. Then my spacing for 0. And finally, 1 wedge going down. So when you look at this, okay, here's our number right here, 24. This number right here is 0, all right? And then this number here we know is 1. But when you add in the fact that they were base 60, this is how it works. This is really 24 times 60 to the 0 plus 0 times 60 to the first, and then 1 times 60 to the second. So 60 to the second, 3,600. 0 times 60 obviously is 0. And 24 times 60 to the 0. Remember, 60 to the 0 is 1. So it's just 24 times 1 or simply 24. And when you add these straight down, that is how we get our number. That's exactly what we're looking for. So it was really nice, whoever this was, to say, well, you know what? We have this staff. Why don't we just use it a different way to represent different place values? All right. And all of this, all the technique, all right, that they used, all right, is called, actually has a very special name. All right. And it's, sorry, I had to cough off camera. So all of this is called cuneiform. All right. And this means wedge shaped. So the Babylonians were extremely effective with how they wrote numbers and everything. It was just, they really had to just like figure out how do we manipulate this place value thing, because you never know what you can get sometimes. All right. So how can we take let's say, a number in Babylonian, or I'm sorry, how can we write a number like this? Like 423, using Babylonian numbers, all right? Well, like I said, the thing to remember here, and I'm going to draw like a little box. Maybe this will help. The thing to remember is they were base 60. So we have 60 to the 0, 60 to the first, 60 to the second, 60 to the third, and so forth. Okay? Here's how we want to approach this. In pink, I'm just going to write what these numbers represent. So 60 to the 0 is 1. 60 to the first, obviously, is 60. 60 to the second is 3,600. Oops. And then 60 to the third is 216,000. Now, our number is 423. So we know we're not going to use any of this because that number is too large. And we also know we're not going to use any of this because 3,600 is too large. So now the question becomes, how many 60 to the first am I going to use? And how many 60 to the zeros am I going to use? And it's actually much easier than you think. All right. So if I were just to use basic division here, 60 will go into 423 approximately 7 times. All right. So what I know is of these 60 to the first, I can use 7 of them. So here's 1, 2, 3, 4, 5, 6, 7. All right. So that gets me all the way up to 420. All right. Now I have 3 left over, so that's just going to be 1, 2, 3. Now, how would we write this number? And right now, hopefully you already see the issue with, if they didn't have that 0, you can already see the issue with this. So what I'm going to do is this. We're going to write our 7 first. And I will leave a big space here in the middle because I'm not skipping any place values. So this would be the number right there. Okay, here are the Mayan numeration system. All right, so we have our numbers here. This is how they wrote out their numerals, okay? But their base was base 20, all right? And honestly, it's a little bit weird, all right? It's a little bit weird because each place value that they had wasn't exactly what you would expect. So let me explain. First, how would they write their numbers? Well, if they wanted to write the number, let's say 42, okay? Or 46. This is how they would write it. All right, this is how they would write the number 46. So notice that their numbers start at the bottom and then go up. So right here, this is our first place value. All right, so this would be 6 times 20 to the 0. That's what that first place value would be, okay? The next place value would be right here. And this would be 2 times 20 to the first. So when I couple these two things together, so I'm just going to rewrite the number off to the right. I'm really going to exaggerate this now. We know this represents 6 times 20 to the 0. We know this represents 2 times 20 to the first. So that ends up giving us 40 plus 6, which is the number 46. All right. But like I said, this is like what you would expect. It gets different after the third place value. So what I'm going to do first is I'm going to show you their first 5 place values. So their first 5 place values are 1, 20, 360, 7,200, and 14,400. And here's how they got them. Oops, wrong marker. This is 20 to the 0. Then we have 20 to the first. Here's their third place value. And it's really 18 times 20. Now, I don't know why it's 18 times 20. All right. But it had to do with, I think, honestly, it had to do with their pyramids. Because if you look at a Mayan temple, let me see if I can find one here. I'm going to have to go to the internet real fast. So let's look up the Pyramid of Kukulkan. Yes, that is a real thing. I'm not making it up. Pyramid of Kukulkan. It's a very famous pyramid. So when we look at this, and this is down in South America. The name of the town or valley is called Chichen Itza. All right, and their pyramids are 4-sided pyramids with a pyramid up top, or not a pyramid up top, like a structure up top. But these stairways right here, don't quote me, but I'm pretty sure there are 90 steps on each side. All right. So that 90, if you think about 4 times 90, that's 360 steps. But then up top here, there's only one entrance and it has 5 steps. So if you think about the number 360 plus 5, that's 365. And that is the number of days in our calendar. So their pyramids were actually a living, breathing calendar. All you had to do was look at it. And what's really special about this pyramid, all right, is going to be the snake head at the bottom. So let's see if I can find a picture of the snake head. There it is right here. Okay. So what's really interesting about this pyramid is it has snake heads at the bottom. In fact, let's see what this is. What's this a picture? Don't care about that. Well, anyways, what makes this so special is if you watch a time-lapse video of the sun or the shadow of this pyramid, and you can kind of see it right here. So in this picture right here, do you see how like you have like these like little, the shadow of the stairs? Oh, here's an even better picture right here. All right. On June 21st, let me think about this. Yeah. On June 21st and December 21st. Those 2 days are very important for us. They are the summer and winter solstices, which is like the first day of summer and the first day of winter. Well, on the first day of winter, as we go around the sun and we have the shading, if you watch a time-lapse video, this will look like the snake is going down into the ground. And that is how the Mayans knew, oh, today's the first day of winter. So they knew, if they already didn't know that the temperature was going to get colder and everything, but they did know that this was going to be the first day of winter. And it's just crazy how all this just like fits. But anyways, this is not a history course. This is a math course. So we're going to go back to this. So this number right here then would be 18 times 20 to the second. And here we have 18 times 20 to the third. All right. So if we wanted to take a number, let's say 7,300, and we wanted to write it in Mayan numerals. All right. Well, the first thing we got to figure out is what place value are we going to start with? And then how are we going to draw our numbers based off that? So like, for example, we know 7,200 is less than 7,300. So I know I'm going to have this place value right here, which is the 4th place value. Okay. So now I have 100 left over. All right, so I would use this place value right here, which is our second place value, and I would need 5 of these. So here's how this is going to work. First place value, second place value. I need a little bit more space. First place value, second place value, third place value, fourth place value. Now I'm going to need one of these 7200s. So I need one of these. So I would just put a big dot there. All right. Now, how many 20s do I need? Well, I need 5 of them, because 5 times 20 is 100. So I would need 5 of these. So that would just be a line. But now how would I write this? Would be like this. I need a symbol for the very first place value. And the symbol that they used for 0 looks like that. So this would be the 0 for the very first place value. Then I would have a 5. Then I would have another 0. And then I would have a dot. And this number right here is 7,300. So that's how you translate into Mayan numerals. The other way is up here, and this is how we go from Mayan into decimal. Okay? So that's going to be it for this video.